In the previous video, we worked together on finding the parabola's vertex without the use of calculus. It can be done. This time we're going to find it with the use of calculus, which, to be sure, is actually much easier to do. But we do need to know the necessary prerequisites in order to do it and in order to understand what we're doing. So if we have the general parabola f of x is equal to ax squared plus bx plus c, and we have our Cartesian coordinate plane, the x-axis, the y-axis, we have some general parabola. The question is, how do we find that vertex? But notice that the tangent line through that vertex must have a slope of 0. So the tangent line must here have a slope of 0. This means all we have to do is first find the derivative of f of x, of this function here. That derivative will tell us the instantaneous slope along any point on that parabola. So what is the slope of any tangent line? Then the question is, when does that slope ever equal 0? So you set that equation to 0 and then solve for x, and you'll get the x coordinate, you'll get the vertex. So we have the function f of x is equal to ax squared plus bx plus c. Let's find the derivative f prime of x, or in different notation, df dx. That's just, well, here we're going to apply basic differentiation rules. So this is one of the major prerequisites. So what's the derivative of ax squared? So we think about the power of 2, so we bring the 2 down, so we have 2a, and then x squared, we always minus 1 power, so it's just an x. Likewise, bx, so what's the derivative? So x is to the first power, so b is going to be times 1, and because x is to the first power, 1 minus 1 is 0, x to the 0 power is 1, so we're just left with a b. And then for c, the derivative of any constant is just 0. So here is our important function. It will tell us the slope, instantaneous slope, of any point on that parabola. Let's just set it equal to 0. So we'll say that df dx is equal to 0, is equal to 2ax plus b. We'll solve for x, so we get negative b is equal to 2ax. So therefore, x is equal to negative b over 2a. It's really as simple as that. So we found it. In other words, we can also think about this in terms of a limit. So we have the limit of delta x as it approaches 0 of f of x plus delta x minus f of x over delta x. And then we're also going to set whatever that happens to be equal to 0. The same thing. So let's work on that. But to solve that, we better first think about what is f of x plus delta x. So remember, of course, we have f of x is equal to ax squared plus bx plus c. So we want to know what f of x plus delta x is. We have a times the quantity x plus delta x, that quantity squared, plus b times x plus delta x plus our c. Let's expand that out, so to speak. We'll multiply that out. So we have a, so x plus delta x squared. So we have x squared plus 2x delta x plus delta x squared plus, we have this here, bx plus b delta x plus c. Okay, so that is f of x plus delta x. So we want to know the limit as delta x approaches 0 of x plus delta x. So that's just our a, let's just work on that part, ax squared plus 2ax delta x plus a delta x squared plus bx plus b delta x plus c. And that is minus f of x, so that's minus ax squared plus bx plus c over delta x. Well, certain things are going to cancel out. So notice this negative here. So we have positive ax squared. Here's a negative ax squared. Those go away. Here's a positive bx. Here's a negative bx. Those go away. Here's a positive c. Here's a negative c. Those go away. And so right now, we have the limit as delta x approaches 0 of 2ax delta x plus a delta x squared plus b delta x over delta x. And by the way, this is supposed to equal 0. We can simplify this, so let's factor delta x in the numerator. So we get the limit as delta x approaches 0 of delta x times the quantity 2ax plus a delta x plus b. It's over delta x is equals 0. We have delta x over delta x. Those go away. So now we have the limit as delta x approaches 0 of 2ax plus a delta x plus b, which is supposed to equal 0. We can easily substitute a 0 for the delta x here without running into any undefined or indeterminate answers. So delta x is going to 0. This just drops out. So now we get 2ax plus b for this here, and that's equal to 0. So again, we'll solve for x. So x is equal to negative b over 2a, and that is indeed the x-coordinate of our vertex. And we can do it through calculus. We can do the limit if we want to go through a limit process, or just apply the quick and fast rules of differentiation to just find the derivative here of that ax squared plus bx plus c to derive this 2ax plus b, set it equal to 0, and boom, we are done. So this is a way to derive the vertex. So we found out the x-coordinate. In terms of the y-coordinate, well, clearly it's just going to be f of negative b over 2a. So we can just put that in and figure that out. I hope this video has been helpful, and good luck to you.